To find the relative extrema at points of inflection, you first need to find the first derivative. It's a quotient rule. So you got to derive the first, which would be 1 over x, leave the second, which would be x, minus, leave the first, derive the second, all over the bottom squared. And that actually looks a little bit easier than I thought. That would go to be 1 minus ln x over x squared. That's the first derivative. Is that good? Okay, the second derivative, we need that for the points of inflections. We derive this. So you derive the top, which would be 1 would be 0. And then ln x is 1 over x would be negative 1 over x times x squared. Is that right? Minus, leave the top, 1 minus ln x times the derivative of the bottom, which would be 2x, over x squared squared would be x to the fourth. And that ends up looking like it'll be, well, won't this be a negative x right here? So it'd be negative x, and this looks like it'd be minus 2x times 1 minus ln x. Are we good? Now, this is going to be kind of weird, but how do I say this? And if we distribute this, looks like you end up with, what is it on top? Distribute this would be negative 3x, because you have negative 2x plus this would be negative 3x. And when you distribute this, don't you get a positive 2x ln x over x to the fourth? Which y double prime, can't you pull an x out, cancel with the x to the fourth? I can pull an x out of both of these, cancel with this, so I get negative 3 plus 2 ln x over x to the 3. Okay, that is it. Now that is the derivative. Second derivative, that is the first derivative. Now, to find extrema, when you set the bottom equal to 0, okay, what do you get? You get x equals 0. Now, can you plug 0 into here? No. This does not exist. So we ignore that one. But when we set 1 minus ln x equal to 0, I can move this over and end up, when I rewrite this, I end up with ln x equals, when I minus this over, I get a negative. So when does ln x equal 1? Well, when does ln x equal 1? Isn't that when x equals e? Because you minus this over, it becomes negative, but you divide by negative 1. So when does ln x equal 1? It's at e. So when x is e, you have a relative max or min. What type? We've got to still figure that one out. When we plug this into this right here, what's ln e? Isn't that 1? So this is 1 over e. So the coordinate is going to be e, 1 over e. And what is it? Well, let's plug e into this down here. And all we care is the positive, negative. When you plug in e down here, all right, what is y double prime of e? Y double prime of e will be your second derivative test. When you do that, we end up with a positive on the bottom, and this is a 1, So negative 3 plus 2 is a negative. So isn't this going to be a negative? So since it's a negative, it's downhill, so this is a max, or a relative max. And what about this for points of inflections? Well, do I need to set the bottom equal to 0? No, that's going to be 0 does not exist. So if we set the top equal to 0, when we set the top equal to 0, the bottom you can kind of ignore. So the top equal to 0, you get ln x equaling 3 over 2 or negative 3 over 2. Looks like 3 over 2. So when does ln x, when you solve this, you get ln x equals 3 over 2. When you solve this with natural logs, do you understand the base is e? So what you do is this ends up being x equals e to the 3 over 2 power, which is a number. You can solve this to this. It's kind of getting squished for space. If I plug this back into the original, I'll just tell you your coordinate ends up being e to the 3 over 2 comma 3 over 2 e to the negative 3 over 2. That's what it ends up being, the y value when you plug that into this. This is the coordinate. And I didn't leave myself enough space, I'm realizing now. But this is going to be a point of inflection. Okay, how do I know? What do you have to do to verify? You choose a value on both sides of e to the 3 over 2, and you'll notice that the concavity changes. You actually have to check that. A lot of times you don't. Again, 0 did not work. We noticed that right off the bat because 0 doesn't exist. But you have to check both sides to verify that, but we're not going to do that at this moment.